Okay, so we've got a vertical reflection. The blue graph was the original. The red graph is the image. And a vertical reflection has a negative outside the function. So technically, if you left your answer like this, with a negative with brackets like this, it's perfectly fine, 100%. Okay? But I am going to propose a problem as if this was a multiple choice question, or you had some options and you had to tell me which of the options is correct and which are wrong. Because there are some mistakes that are made, common mistakes, when simplifying this. So I'm going to give you 3 different colors. First of all, what do you do with this negative out in front if you simplify it? Okay, option number 1, I'm going to put that negative with the 1. Okay? I'm not telling you if this is right or wrong. You can decide on yourself. Am I allowed to do that? I'm not telling you. Maybe that's completely wrong. Option number 2, I'm going to take that negative and put it everywhere. So negative on the top and negative on the bottom. And if I put the negative on the bottom, I'm going to have to distribute. There we go. It's a different answer than the green one. Or option number 3, well, I did negative on the top. I did negative everywhere. I'm going to do the negative on the bottom. Okay, so I have 3 answers there. This is your question for you. Are all 3 right? Are all 3 wrong? Is only 1 right? Is only 1 wrong? If you say only 1 is right, which is the one that's right? If you say only 1 is wrong, which is the one that's wrong? Algebraically, how do we deal with that negative? So in your head, you determine which are right, which are wrong. Make up your decision what you think you would do. Tell me when you're ready, and I'll tell you the answers, and we'll explain. Or here, we'll do, here, no, that won't work. I was going to say, if you think number 1 is right, put this finger up, and then I was like, no, this is not going to work. Let's see. Let's just, this will work. You have to answer no matter what, okay? If you think one of them is right, you will put up your right hand. If you think it's wrong, you'll put up your left hand. So when I go to the green, if you have no idea, you could, which is really obvious that you have no idea, so you might want to. Hello.
At the end of class, can I have Josh to the office for a quick moment?
Yeah, no problem.
Thank you.
Oh, I think they said Josh. They didn't say Josh. So I think it's, but if it's wrong, they'll figure that out after. Okay, so if you think the green one is right, right hand. If you think the green one is wrong, put up your left hand. So everybody should have their hand up, no matter what. Just wait, just wait. I'll do it on the count of 3. If you have no idea, you might want to make a decision. All right? First one. Okay? Second one. I can't remember which hand's right. Okay? Third one. All right. Okay. So, mathematically, the first one is right. The second one is wrong. The third one is right. What? What? Okay. So, why and what happened? When we have a negative out in front of a fraction, that's like having a negative 1 out in front of the fraction. A negative 1 out in front of the fraction could be seen as negative 1 over 1. I could write it as a fraction because we have rules for how we multiply fractions. When you multiply fractions, you multiply the tops, you multiply the bottoms. So if I write the negative as a negative 1 over 1, I would multiply the top by a negative 1, which is the green one, and the bottom by a positive 1, which wouldn't change it. That's why the green one is correct. Does that make sense now that you look at it that way? Okay? If the black one, which is wrong, where I did the negative everywhere, if I did a negative on the top and a negative on the bottom, what's a negative 1 divided by a negative 1? A positive 1. So that cancels the negative out. So that is why the second one is wrong. But you're so used to negatives outside of like x plus 3 and distributing, and you're used to going, oh, the negative goes to everything, you you wanted to take this idea and apply it here and make the negative go to everything. So we have to be careful. We have to be careful that we don't apply some math rules that work in some situations to situations they don't work. But having that negative 1 out in front, does it make sense that I could also have said it was 1 over negative 1, in which case the top would stay the same. And on the bottom, I would have to distribute, making the purple one. So that is why the purple one is right as well. Okay. So, questions for practice here are 7, 8, 9, and 12. And I have a note that I think we should do 12 together. So let's turn to question number 12 first. Oh, yes. It gives us a graph. It gives us an equation, a function. F of x is x squared plus x minus 6. Okay? When you see an algebraic equation, one of the things that should come to mind is its graph. And sometimes you know its graph exactly, and sometimes you know its graph just kind of generally. In this case, I would hope that you would just say, that's a parabola. I don't know exactly where that parabola is, but it looks like this somewhere. It opens up because the x squared is positive. That much I know, but where it is exactly, I'd have to do a little bit more analysis or table of values to figure out exactly. Then it says in this question that if you flipped it vertically, up and down, okay, where would it intersect? Well, if I flipped it over the x-axis, it would depend where my x-axis is. If my x-axis is here, can you see that if I flipped it, it would not intersect at all? But if my x-axis was here, and I flipped it, those would be the places it would intersect. Does that make sense? So part A is just a a different way of asking this question is asking what are the x-intercepts of f of x equals x squared plus x minus 6? But it's not it's not easy to see right at the beginning that that's what it's asking. What did I have to do that? I had to create an idea of what the graph was, even though I didn't know what the graph was exactly. I imagined flipping it and saying, oh, the only way it intersects is if the x-axis goes through it and it has two x-intercepts. If it's above the x-axis and it flipped, there would be no intersection. So then I realized that this question was the same as just asking, what are the x-intercepts? And this is a review question from grade 11. So now we get a chance to review a concept from grade 11. How do you find x-intercepts algebraically? I mean, if you have the graph, you can maybe just see them, but we don't have the exact graph. We find an x-intercept. Every x-intercept has a y-coordinate that's 0. So we set y equal to 0 and solve. So if I put 0 in for y, I now have the following equation. 0 equals x squared plus x minus 6. This is called a quadratic equation. You solved them in grade 11. Quadratic because of the squared. An equation because it has an equal sign, and the only thing you have to solve for is x. In grade 11, you learned 3 techniques to solving these. Do you remember one of the techniques? 2 of the techniques? Do you remember all 3? Okay. The most common technique that people did to solve this? Factoring. Factoring, where you change this to brackets, right? And to get x squared, it would have to be x and x. To get a 6, could be 6 and 1, could be 3 and 2. How do we know which one it is? Well, when you multiply, it's going to be 3 and 2, I'll tell you that much. It's going to be plus 3 and minus 2. When you multiply this out to check, the first ones, in English we sometimes use first, outside, inside, and last. We sometimes use that as a way to help us remember what we're figuring out. If we look at the first ones, they give us the x squared. The last ones have to give us minus 6. But the outside, in this case, minus 2x, and the inside, plus 3x, have to combine to give us 1x. So this is factoring. If you factored it, then you get our answers are x equals minus 3 and x equals 2. Oh, factoring is so important. Now, the reason why factoring is so important is because you change something that's adding to equal 0 to something that is multiplying to equal 0. And why is that so important? Here. Okay, I have 2 numbers in my head. You just have to tell me one of them. I add them together, and they equal 0. What are the numbers in my head? Feel free to guess. 2? No. 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 You just have to get one of them. No. 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 They were 3.7 and minus 3.7. Oh, with a decimal, that's not very nice, right? Okay. How long would you have to guess? Forever, it feels like. You could probably guess for a very long time before you'd be like, can we play warmer, colder, or something like that? But as soon as you change it to multiplying, okay, I'm going to pick 2 new numbers in my head. You just have to tell me one of them. They multiply, and they equal 0. One of them has to be 0. That's the only way. The other one was 7.3. Okay? But the one was 0. It would have been terribly ruined my whole lesson had someone said 7.3. I'd have to say, yes. But that's, yeah, okay. So the reason that's so important is because as soon as you change them to multiplying, that tells you either this one is 0 or this one is 0. And if this one is 0, then x is minus 3. And if this one is 0, then x is 2. And now you've solved it. That's the reason we factor. And that's why it's so powerful. What happens, think back to grade 11, what if we weren't able to factor it? What did you do in those questions? You could complete the square. That was method number 2. Ooh, here's people like, I don't want to complete this. What was method number 3? The quadratic formula. The negative b plus or minus square root of b squared minus 4ac all over 2a. Remember that one? It's on your formula sheet this year. So, okay. All right. 12b. 12b says, what happens if you had y equals f of negative x? So we knew that f of x was a parabola. What does this mean? Horizontal reflection. So it's going to reflect over the y-axis. Let's say I draw a y-axis. What point, where do they cross when you reflect it over? This is asking to find the y-intercept. How do you find a y-intercept? If you find an x-intercept by plugging in 0 for y, you find a y-intercept by plug in 0 for x. So, you'd have 0 squared plus 0 minus 6. So it intersects at 0, negative 6.